Hello children, welcome to Math Park. In our park, today we are going to learn about rational and irrational numbers, the first chapter of class 9 ICSE, and here we start with very first exercise, exercise 1A. Do watch till end and we are coming up with the each and every exercise of this chapter again. So if you are new to the channel, please like, share and subscribe. So here we go. So the first question of exercise 1A, is 0 a rational number? Can it be written in the form of P by Q, where P and Q are integers and Q is not equal to 0? So any number which can be written in the form of P by Q and Q is not equal to 0 is a rational number. So can I write 0 as 0 upon 1? So 0 can be written as. So this is definitely 0 is a rational number as. Yes, 0 is a rational number as we can write it as 0 upon 1, 0 upon 2, 0 upon 5, 0 upon 100, whatever. So this is how it can be written in the form of P by Q where Q is not equal to 0. So denominator 1, 2, 3, 4, 5. If you divide 0 by any number, the answer is going to be 0 itself. So that is how 0 is a rational number. Okay, the second question, are the following statements true or false? And you have to give reasons for your answers. So every whole number is a natural number, right? Is it correct? Every whole number is a natural number. Natural numbers are the numbers which are seen in the nature, and whole numbers start from 0. So this is false because 0 is a whole number but not a natural number. So the smallest natural number is 1. Natural numbers begin from 1. The smallest natural number is 1. So that is how 0 is not a. Every whole number is a rational number. Is it true or false? Yes, it is true because every whole number can be written in the form of P by Q, right? So if it is a whole number, so we know that whole numbers are 0 is a whole number, I can write as 0 upon 1. Okay, 1 is a whole number, I can write as 1 upon 1. 200 is a whole number, I can write 200 upon 1, right? So that is how every whole number is a rational number because it can be written in the form of P by Q and Q is not equal to 0. So third part of question number 2, every integer is a rational number. Can every integer be a rational number? Yes, it can be. How it can be? So we know that any integer. So integers are -1, -2, all whole numbers and their negative. 0 is neither negative nor positive. So -1 is an integer. I can write it as -1 upon 1. 5 is an integer, I can write as 5 upon 1. So that is how every integer is a rational number because we can write it in the form of P by Q or M by 1. If I take M as an integer, got it? So every integer is a rational number, remember. Then the fourth part, every rational number is a whole number. Can every rational number be a whole number? No, false. Because let us take one example of 3 by 5 as a rational number. So 3 by 5, is it a whole number? No, it is. It is not. It is a fraction. It cannot be a whole number, right? So 3 by 5 is not a whole number because whole numbers are 0, 1, 2, 3, 4, 5, 6, 7, 8 and infinity. So this is how every rational number, whole numbers start from 0. Right? They are infinite. So fractions, whole numbers are never fractions and rational numbers can be fractions as well. So that is therefore every rational number is a whole number is a false statement. Arrange -5 by 9, 7 by 12 and -2 by 3 and 11 by 18 in the ascending order of their magnitudes. So remember children, whenever we are arranging the fractions, we have learned about ascending and descending order of fractions. So we have to look for converting them into like fractions. That is, the denominator has to be equal. For that, what we do is we take the LCM of the denominator. So LCM of 9, 12, 3 and 18 is 36. So we convert each of these rational number into equivalent rational number with denominator 36. So 5 by 9. So 9 should be multiplied by what to get 36? So we get 9 multiplied by 4 is 36. 9 into 4. So we have to multiply to the numerator also. So 5 by 9 is same as -5 by 9 is same as -20 upon 36. Same thing we will do for 7 by 12. Now 7 by 12. 12 into what? 12 into 3 gives 36. 7 3s are 21. So 7 by 12 can be written as 21 by 36. The next is minus 2 by 3. So 3 into 12 is 36. So minus 2 multiplied by 12 is minus 24 by 36. And then we have 11 by 18. 18 2s are 36. So 11 2s are 22. So this is how we get the equivalent rational numbers. All the denominators are 36 now. Let us arrange them. So here when we can look at the numerators. We know that minus 24 is the smallest, then comes minus 20, then comes positive 21, and then comes 22. So then we arrange them. So minus 24 by 36 is the smallest, then comes minus 20 by 36, then comes 21 by 36, and then 22 by 36. So original numbers when we write here, minus 24 by 36 is nothing but minus 2 by 3. Minus 20 by 36 was minus 5 by 9. 21 by 36 was 7 by 12. And 22 by 36 was 11 by 18. So this is how we arrange the given rational numbers in the ascending order. Now we are asked to find the difference between the largest and the smallest number. So which was the largest here? The largest was 22 by 36 and the smallest was minus 24 by 36. Minus of minus becomes plus. So this becomes 22 by 36 plus 24 by 36. Like fractions, we write the denominator once, we simply add the numerators. So 22 plus 24, you get 46 by 36. Both of them, the HCF is 2, divide by 2, you get 23 by 18. So this is how the difference between the largest and the smallest number is 23 by 18. In the mixed fraction, we can get as 1 5 by 18, and 5 by 18, when I convert into decimal, I get as 0.3. So it is 1.3 correct to 1 decimal place. The next question now, we have to arrange 5 by 8, minus 3 by 16, and minus 1 by 4, and 17 by 32 in descending order of their magnitudes. Descending order, big to small. Again, look at the denominators, 8, 16, 4, and 32. So we will be finding the LCM of that. And again, you are asked to express the result obtained. You are also asked to find the sum of the lowest and the largest of these rational numbers and express the result as a decimal fraction correct to 2 decimal places. So first we find the LCM. To arrange this, we find the LCM of the denominator. So LCM of 8, 16, 4, and 32 is 32. Now we convert each of the rational number as denominator, equivalent rational numbers with denominator 32. 8 4s are 32, so 5 4s are 20. Minus 3 by 16. So 16 2s are 32, minus 3 times 2 is minus 6. So we get minus 6 by 32. And minus 1 by 4. 4 8s are 32. So minus 1 into 8, we get minus 8. And 17 by 32 remains as 17 by 32. Got it? Now we have converted them into like fractions with the denominator same. All of those are the LCM of the given denominator 32. Now we arrange them in the descending order. So first we can see, let us see in the minus 8 is the smallest, then minus 6, 17, and then 20. We have arranged in the ascending order. So the ascending order would be this, minus 8 by 32. But we are asked to write in the descending order. So biggest is going to be 20 upon 32. So now arranging in the descending order, we get 20 by 32, 17 by 32, minus 6 by 32, and minus 8 by 32. So original rational number 20 by 32 was 5 by 8, 17 by 32 was 17 upon 32 again, and minus 6 by 32 was minus 3 by 16, minus 8 by 32 was minus 1 by 4. So we have arranged the given rational numbers in the descending order. Now you are asked to find the sum of the lowest and the largest fraction. So the lowest is minus 1 by 4 and largest is 5 by 8. So minus 1 by 4 plus 5 by 8. So the LCM of 4 and 8 is 8. So we will be multiplying by 2 here, multiplying by 2 here. So minus 1 into 2, you are going to get minus 2 plus 5 upon 8. Minus 2 plus 5 is 3 upon 8. And 3 upon 8 is 0.38. Since we were asked to express the answer in 2 decimal places. Got it? Let's move on to the last question of this exercise. This question was already solved by me in another video. The link of that you will find in the description. So remember here, when we have to identify whether the given rational numbers will have terminating decimal or non-terminating decimal, we just have to look at the denominator. Denominator is 16. So what is the prime factorization of 16? It is 2 multiplied by 2 multiplied by 2 multiplied by 2. So it will be 4 times when we are multiplying 2, we are getting 16. So every time you can see that the denominator has the factor only 2, right? This is why it will be a terminating decimal. Since the only prime factor of 16 is 2, we get this as terminating decimal representation. So you have to remember that if denominator of rational number has factors 2 or 5 or 2 and 5 both, only then it will be a terminating decimal. Any other number other than 2 and 5 is the factor of the denominator, that rational number cannot be terminating decimal. Okay, let's take the second part of this question. And the second part is 23 by 125. So 125 is cube of 5. So 5 into 5 into 5. Only 5 is the prime. So definitely 23 by 25 must have a terminating decimal representation. Just remember 2, 5, or 2 and 5 both, nothing other than that. The third part of this question is 9 by 14. Denominator is 14. The factors of 14 are 2 and 7. 7, which is not acceptable. So since the denominator has factor 7, 9 upon 14 will not have terminating decimal. So just remember again, the denominator should have the factor either 2, only 2, only 5, 2 and 5 both, or else nothing other. If it is so, the given terminator will not have, given rational number will not have terminating decimal. Okay. The next part of this 32 by 45. Let us find the factors of 45. So factors of 45 are 3 3s are 9, 9 5s are 45. So will it be terminating or non-terminating? Of course, non-terminating, because 3 is cannot be there. So the prime factors of 45 are 3 and 5. So 32 by 45 will not have a terminating decimal representation. Got it? Okay. 43 upon 50 now. 43 upon 50. Find the factors of 50. Denominator is 50. 2 into 5 into 5. 2 5s are 10. 10 5s are 50. Yes. So the prime factors of 50 are 2 and 5. So 43 upon 50 must have a terminating decimal representation. 17 upon 40. Find the factors of 40. So 40 is 2, 2s are 4, 4 2s are 2 2s are 4, 4 2s are 8, and 8 5s are 40. Only 2 and 5. So yes, it is going to be a terminating decimal representation. Okay. 61 upon 75. The denominator is 75. Find the factors of 75. So 3 5s are 15, 15 5s are 75. No, it is non-terminating. So the prime factors of 75 are 3 and 5. So 61 upon 75 will not have terminating decimal representation. 123 upon 250. So the last part of this exercise, question number 5, 123 upon 250. The denominator is 250 here. So let us find the factorization of 250. So finding the prime factorization of 250, we find it as 2 into 5 into 5. 2 5s are 10, 10 5s are 50. 50 into 5 is 250. So only 2 and 5, right? So the prime factors of 250 has only 2 and 5 as factors. So yes, 123 upon 250 is having a terminating decimal representation. Did you understand this exercise, children? If you like the video, please share with your friends. If you are new to the channel, subscribe it. Thank you for watching. Have a good day.